In this video, we will learn how to specify GD&T in CATIA. We have imported a shaft in this space and completed some GD&T symbols on these components. We have this tree to show our specification, including datum D and E datum, and the datum reference frame. We have D and DE reference frame, and the geometric tolerance specification, including flatness, perpendicularity, position surface profile, position surface profile, and position, and following dimensions. And we have also some construction geometry. Now let us start from the beginning. From these components features characteristics, we know this flange surface will be installation with another parts. The flange will have 5 dot holes. The installation process should be the face should be installed on another face. Then we have a concentricity installation for the axis. Let us enter into the FTA mode. In these two bars, we have automatic and wizard method to specify GD&T on these components, and we also have some customized manner to specify, but we recommended use this wizard to complete the components GD&T specification, because this wizard has some intellectual judgment whether the GD&T specification is correct or not. And if we completed our GD&T drawings through this command, and this GD&T specification and GD&T symbols could be easily exported to other software such as SolidWorks, CNDCS, 3DCS. Now let us begin to specify the datums from the primary datum, then second datum. Select this command, select this face, and we specify this as datum A, automatic give symbols. Then we select flatness. We give the value. We also can give some modification symbols, such like freedom, free state, and statistical tolerance. This will be added in the control frame. We need to adjust the position. Now we can see we have a specification on the drawing. Flatness has been specified on this red surface, but somebody will think we would like to have another direction for this symbol's place. We need to use this symbol. Then select the surface we would like to place. Then keep this. We have a new active front views for our for our specification. We could check this. Except for the specification, then beat it. Then we can lightness. You can see we have this direction symbols with perpendicularity with our original ones. You can keep this, delete. If we want to change the size of the font, we could use this, usually 3.5 or double size. Then we complete the main datum. Main datum means our assembly line use this surface as the first step to install this shaft to our craft interface. Then we need to specify this cylinder. This cylinder should be the second datum. Second datum should be have relationship with the first datum, the primary datum. Primary datum should be the relationship in perpendicularity. Then we select this surface. We have a recommendation, the diameter and datum. We need to select diameter at first. This is inch. We need to change metric, millimeter. So this is the diameter of this circle. We could give a tolerance. This is symmetric lower limit. We can have some symbol independency for flexible parts, just like rubber parts. Statistical tolerance are free state. We just keep this specification. Now we could give the specification just like perpendicularity, but we haven't any perpendicularity symbols here because we need the datum A for this perpendicularity specification. So we need to add datum. Add A datum. We have only A datum, cannot be modified by MMC or LMC. So then we select datum, select the diameter. Then we have this symbol, GD&T symbol. So we click this. Then we have the specification requirements for the perpendicularity. Now we can give M symbol or F symbol, statistical tolerance symbol. It depends on our requirements. Then click OK. Then we complete this item B requirements. This is a group symbol. We can adjust the position for this, and we can also have this symbol to change a more suitable place. Back to the specification requirements. If we select the cylinder directly, use datum at first. or we change another specification. Just select this and select perpendicularity. We cannot have MMC symbols inside of our control frame because we haven't the diameter requirements. MMC means this perpendicularity GD&T symbol should be related to its size dimension. This we call FOS. So we need to have symbol. We need to define the symbol, define the diameter at first, give the tolerance for the diameter, for the size tolerance. Then we have GD&T tolerance and have MMC requirements on our control frame. This is was automatic judgment for our specification. It's a very useful method to help us to have correct specification on our drawing. Let us complete the datum requirements for these components. We have the second datum B. To observe these components, after A and B datum specified, we have actually completed control these components manufacturing because the following components, 5 holes and shaft they are all 360 degrees symmetry. So this is a revolution part. We need not only have 2 datums is enough. We need not need the third datum. Although the components will turn in our fixture, but any points stop points, we could have the same components manufactured for the 5 holes and the shaft. So for the cost region, we need only 2 symbols, 2 datums. After 2 datums, we can have the other features definition, like this 5 holes for the installation. We can click this, and because we have only A datum reference frame, we need to generate another datum, which is A, and we need, because B is the size tolerance, we can have MMB modified B datum. So we complete this datum creation. Then we can have 5 holes the definition. You can click this, click this, click this. With control on the left mouse button, we select 5 components, 5 holes together. Then there's only one recommendation with n times position requirements, n cylinders in collection. This is a pattern holes specification. So we can have this as requirements. So this is the specification, but we checked there is no MMC requirements. Specific modification could be used. So we need to have a size dimension. We delete this. We click the blank area. So we have this n diameters. N diameters, we need to change back to the mm. So we can give this dimension for this. Okay. Then we have tolerance specification. Recommend use this. We have this dimension completion. Then how this we have 5 times diameter, 9.7 to 9.3. This is our requirements. We could also change this tolerance in properties. In tolerance label, we can change this, just like maximum, just like we maximum upper value, for upper value apply. Then we have some change. This is the new dimension requirements. Then we also have this standard requirements. Currently we use ASME specification. ASME for 3D GD&T definition creation, we need related to 4 standards. This is our standards. But the newest standards for ASME Y14.5 is 2018. But GD&T updated to 2009. It's also very latest one, but we need to notice this. And we also have ISO specification. You can check this. ISO related more specification, so we can have some update on our drawing. We need we come back to, because our decision is still ASME GD&T requirement, so we can change this standard inside of GD&T module space. So we have this datum reference frame AB MMB, and then we can specify 5 holes position. We then select this 5 holes active. Then we have this position requirements. We generate this position requirements to this tolerance. Then we need to have MMC or LMC. Usually we have MMC. This is the specification for the 5 holes requirements. But we need to check this. If this because this tolerance feature, if the thread, because we haven't thread feature added in these holes, so we have no selection for this. And also how this tolerance, and the tolerance zone is especially for projected tolerance zone, and tolerance zone and with tolerance features. These 2 labels are especially for thread features on our components. We will show us how to use this. Then we complete this component definition. This is the result effect. And we have 5 components definition. From this definition, we need to know that this tolerance is MMC specified, and the maximum MMC size of this holes is 9.3, and 9.3 related position tolerance is diameter 0.2 millimeter, and one is 9.5. The position should be 0.4, because I have bonus tolerance from the size tolerance. So 9.5 minus 9.3, we have 0.2. 0.2 plus 0.2, we have the final, the maximum tolerance from position is 0.4. This will be calculated automatically in our our coordinate machine measurement machine. We will show this later on our video. For good drawing, we need to have some constructor feature, like the hole. We can add axis, and this add axis. We also can change the line type to this one. So yeah, the color, we can also change the color. Yellow one. So this would be better for the observer. This is for drawing reading reason. We have some definition. This is the final result. So let us try. If we need to have the thread specification, how to do this. We need to back to our task space. For the task module, we have this symbol. We use this symbol to change our components as the limit face with the thread face. We need to project the surface limit face. Then automatically give diameter. The diameter should be inside of material. So we could click OK. Then we back to this FTA module. FTA module, we can have this command. You can select all command. So this is the thread surface. We just construct it. Then we have this tolerance specification. We have this symbol, thread symbol. We need to have thread size at first. This, if we have page, this will just give this. We have this tolerance. Yeah. You can then give this. So this is the tolerance, and the symbol should not be diameter. We need to change it to M symbol. We need to have inch diameter. So this is for the diameter specification. We need to have this more suitable. So we have the identification because sometimes we need to lower our cost. We have some individual symbols after this measurement. So we keep this symbol on. So then we can have this position requirements. So for the position requirements, we need to have MMC requirements. For the tolerancing those thread, we need to know the tolerance should be on pitch cylinder. The pitch cylinder is difficult to measure, so we usually use measure for the outer thread for our bolt, minor diameter for the nut. This kind of thread. So because this is the hole, this is a hole. So this minor diameter position is easy for measurement. We need not to use plugger or some profile machine to measure this because this three cylinder have good concentricity. So we just use minor diameter represent pitch diameter, pitch cylinder. So if you select the pitch cylinder, we need not have any symbol to show this. We have a minus diameter. We tell our quality team how to measure this, and our supplier manufacturer how to measure this. So this is the requirement. We have the more suitable tolerance for this thread. Then we we will never forget this P tolerance. P tolerance is project tolerance. Project tolerance means we need to have a installation surface. So we create. We need to select a surface. If this surface is installation surface, we need to select this. But actually, we use this surface as our installed surface. Then we give 20.5 for the components we installed thickness, create dimensions. Yeah. Okay. We can check. This is this side. This side. We keep this side. Okay. This offset because if I have some offset requirement, just like this surface is not represented the installed surface, we can change the location. Okay. So we can see the tolerance can be introduced inside of our control frame. It's more follow our specification, our ASME specification and requirements. And that's inside of this. But this is project thickness. Then we have OK. Then we complete this specification. So we complete